Find the distance between the 2 points 6, 1 and 2, 5 using the Pythagorean theorem. Round to 2 decimal places if necessary. Alright, so let's plot these 2 points and see what we mean by the distance. I'm just going to use a scale of 1 on each axis. So then the point 6, 1 is here and 2, 5 is here. The distance between those 2 points is the straight line distance of the line segment that connects the 2 points. So we want to find that distance. I'm going to call it D. Now, one way to do this is to draw a right triangle that connects those 2 points. And so to do that, what we do is we draw a vertical line segment and a horizontal line segment. Notice that that vertical line segment has length 4, and the horizontal line segment also has length 4. And so what I've done here is I've drawn a right triangle with legs 4 and hypotenuse D. So then by the Pythagorean theorem, I have 4 square plus 4 square is D square, or 16 plus 16 is D square. So then 32 is D square. I'll just turn things around a little bit. D is then equal to plus or minus the square root of 32. Now, D is a positive value because it's a length of a triangle. So D is the square root of 32. Or recalling, using our properties for square roots, since 32 is 16 times 2, I can write D is equal to 4 times the square root of 2. Now, it says we can approximate this, so D is approximately 5.66 units. Exercise B asks us to find the distance between the 2 points -3, 2 and 5, -4 using the distance formula and round to 2 decimal places if necessary. So the distance formula is just a way to express the Pythagorean theorem without having to actually show the theorem. So the distance formula says that the distance between 2 points is given as the positive square root of x2 minus x1 square plus y2 minus y1 square. And if you look at this, notice we have this quantity squared plus another quantity square, and then we take the square root. And that's, if you think about the Pythagorean theorem, that should sort of make sense. Alright, so we'll call the first point our x1, y1, and the second point is our x2, y2. Making appropriate substitutions, we would have 5 subtract -3 square, and let's see, y2, that's -4, subtract y1 is 2 square. So then D would equal, let's see, 8 square plus -6 square. D would equal the square root of 64 plus 36. D would equal the square root of 100, and so then D would equal 10. Notice how the distance formula is already in terms of the positive square root, so we don't have to make that decision. It's already there for us. So then the distance is 10.